Okay, Kenzie, I'm ready. Go ahead.
Okay. One second. What was I gonna ask? Sorry.
No worries.
So I guess where I keep getting confused about on like these kinds of problems is so you have the graph and so it's asking for like these values of g, and I'm confused whether I should use like the fundamental theorem or whether I should find the area of like that shape of the shapes in the graph, or does that make sense?
Yes. Let me see if this helps. So part of what you're asking about is, again, how they will present problems year after year that have kind of the same look and feel, but then they make the problem just enough different that it tends to confuse you. So it's a really valid question. So let me talk for a minute, then I'll maybe ask you some questions. So first thing, when I read the problem, I try to train myself to not think of a previous problem necessarily. I just try to use whatever they give me. So in this case, as I started reading, here's what I was thinking. They say the function g, so I make a note that I'm talking about g, is defined and differentiable. Differentiable could be important, I'll underline that. And this definitely will be important. I've never seen a question where I didn't use that, the g of 0 equals 5. But so far I don't really have any clue what I'm supposed to do, so I just keep reading. The graph of g prime is shown above. So this is g prime. Okay, then they say find g of 3. Here's what I remember. It's back to what I used on the last problem. So even though you get to use notes this year, I'm constantly trying to find ways to show you that the problems have much in common. Therefore, you can often use the same kind of strategy in different problems. So in this case, g is a rate. They're asking me to find g of 3. But they didn't really give me any information about g other than g of 0 is 5. What they did give me is they gave a whole bunch of information about g prime because they gave me the entire graph of g prime. Kenzie, you with me so far?
Yeah.
Any questions from Amanda or Julia so far?
No, good.
Okay. So the big clue is I'm trying to find g of 3, and I have g prime. You just need to memorize that that's a fundamental theorem. So I think making this little chart is really helpful. It doesn't take very long once you do it a few times on problems, and it helps show you right away which way you're trying to go. So because I'm going from here, rate to amount, that's the fundamental.
So I know if you integrate the rate, you get the amount.
Exactly. You actually get the change in the amount. And so that's why I went straight to this on my notes right here. Because just what you said, Kenzie, if I integrate the rate, I get how much the amount changes.
From B to A.
Correct.
Okay.
So what do we want to choose as B in this problem?
What do you mean?
So we've got to use the fundamental theorem. So
we use 3.
Perfect. So I'm going to integrate. I'm going to put a 3 here. Still see the board okay?
Yeah.
What do I put on the bottom? What's the lower limit of the integral, Kenzie?
I want to say 0 because we give you that, or...
No, it's perfect. And then what are we integrating?
How do you, make sure you have the right range for the integral?
So when I use the fundamental theorem, there are different ways you use it, but one of the most common ways is I make the limits, so the 0 and the 3, I make one of those limits, like, hold on, don't let me forget your question, but let's do one other thing. What are we integrating in this case?
What do we integrate? We're,
Like, what do I write here?
G prime of x,
Perfect. Pause for 1 second.
x.
So your question is, how do you know what limits? Well, this is going to find for you g of something minus g of something else. And what you want to do is you want to choose, but the fundamental theorem says this has to be 3 and this has to be 0. So you chose 0 because you know the value of g of 0.
Okay.
Because what is g of 0?
It's 5.
Perfect.
It's given.
Right, and you chose the upper limit to be 3 because you want to find that.
Okay.
You with me?
Yes.
Amanda and Julie, okay?
Yep.
Okay.
Yep.
So, as I read the problem, I would have done what I showed you over here in white. So I can see that, oh, I've got to use the fundamental theorem. That would have caused me to create what you see here in purple, this one.
And then solve it for G of 3.
Perfect. So I rearranged the equation. 1 second. And the new equation I get is going to look like this. G of 0 was 5, so I'm going to end up with g of 3 is going to equal 5 plus the integral from 0 to 3 of g prime. So I don't even think about area or anything like that until I'm at this point, and now I need a way to compute this integral. That's when I'm going to start paying attention to areas.
Okay. So, I guess, okay, I'm sorry, I'm just trying to think of how to phrase it.
You're doing just great, Kenzie. You just keep taking your time, so.
Okay. Let me just look at my Google Notes real quick.
Uh-huh.
Okay, so I guess kind of where I get confused is, so you have the fundamental theorem, like on the gold notes, it says like integral of b to a f prime of x of dx equals f of b minus f of a. And I guess my struggle is how I'm figuring out how to relate that fundamental theorem kind of to, I guess, kind of what we're doing now.
See if this helps. You said a minute ago that you don't have a problem remembering that when you integrate the rate, you find the change in the amount. Is that correct? Are you comfortable with that idea?
Yes.
So that's what the fundamental theorem is saying. If I integrate a rate, I find how the amount is different or changes over some time period. And what we're saying in this problem is we know the value of g at time 0. We want the value of g at time 3. Well, the integral will tell us. Go ahead.
Maybe I'm getting confused because, like, I understand this, but then finding the value of the integral part of the equation, I guess. Like, I'm confused whether I should take g prime of 3 minus g prime of 0, or I should find the area of from g prime of x from 0 to 3.
I got it. See if this helps.
Makes sense?
Go ahead.
Huh?
Oh, sorry.
Oh, just if that makes sense, what I'm getting confused about.
I think it makes complete sense. Let me see if this helps you. So ignore the graph for a minute. Tell me if you feel comfortable with the fundamental theorem's basic idea alone. That if I know the value of this integral, I'll know how much g changes.
Yeah.
So I'm going to use a simple number to make the discussion easier. Like if I find out that this integral's value is 10, then it's easy for me to say, well, at time 0, g was 5. The integral tells me how much g is going to change, so now I know that g of 3 would have to be 15. Does that feel good so far?
Yeah.
Okay. What you have to do is you kind of have to memorize that part is easy. That part hopefully makes sense. It's easy to remember. It's easy to understand. What isn't so easy to really understand is what happens next, which is we have to have a way to find the value of the integral of g prime. And the way we find that integral is not necessarily intuitive. It's just you need to memorize it. Like if I had an equation for g prime, I'd just type it in my calculator. And this year, because you can always use a calculator, if you have one, just use it. Like if you have a value for g prime, you just plug it in. The integral will the calculator will tell you that this integral's value is 10 or whatever it happens to be. But another way they'll test you is they'll say, no, we won't let you. I mean, you can use your calculator, it just won't help. Like in this problem, you have to be able to find the integral of g prime by paying attention to area. It's just another method, but it is not intuitively connected to the fact that you're finding, like I can explain how it works, but the explanation gets kind of lengthy and it kind of gets hard to remember. So it's probably easier just to say, hey, for this year's test, 2 main ways I'm going to be finding integrals. One is that they give me an equation for g prime, I'll just type it in my calculator. But if they give me a graph of g prime, I'm going to have to use areas to find the value of the integral. When you're finding those areas, you kind of temporarily forget about g at all. You're just finding the integral for g prime.
Yeah. I think I'm sort of understanding.
See if this maybe helps. Do you feel good about this box right here?
Like, I understand, like, that is the fundamental theorem of calculus. I think part of it where I get confused is I want to take, like, the integral part of it and be like, oh, g prime of 3 minus g prime of 0, and then find the integral that way instead of doing the area.
Yeah, that's just, I'm not trying to be impolite. That's just wrong. Like the integral of g prime, let me write it down. The integral of g prime will never equal, like this is never true. I've had hundreds of students kind of think it's true, so you're not alone, but this is never going to work. Is that what you just said?
Yeah.
Yeah, that is never going to work. So
because those have to be not prime. That's a bad way of saying it, but they can't be prime because you're finding basically like.
yeah, the fundamental theorem is what you said earlier. It's this piece.
So, but if you were given the graph of just g of x, it would be able to find, I mean, there'd be no point in finding g of 3, but you'd be able to find that though.
Yeah, no, I like what you said there, that if you were given the graph of g, yeah, it doesn't make sense. They wouldn't test you this way. But there have been questions on tests I've given you so far as practice where they gave you a table of G itself, and they asked you to find this, and you had to find this value by looking at the table for G of 3, and then also looking at the table to find G of 0. Yeah, you weren't using it to find G, you were using it to find the integral of G prime.
Okay, this is making a lot more sense, and I'm understanding where I got confused.
Let me say one more thing that I hope would help. One key to success on the AP test is what I talk about a lot, how you worry about one step, you don't worry about the next step. And you just want to train yourself and practice worrying about one step at a time. For example, what I showed earlier, how we had this idea, that my first thought is, okay, they are giving me, they want G of 3, they're giving me G prime, so I know I need to use the fundamental theorem. So that's how I got to right here, this box here. That was my first thought process. And I didn't think of anything else, I just thought of that all by itself. Are you good to there?
Yeah.
Okay, now the next thought process is, well, so here's where you forget about the first step, and now you just focus on the second step, but you focus on the second step all by itself. I've got to find this integral. Let me show you a box on the golden notes that I put on the notes to help with that. One second.
It honestly seems so obvious now, like, what I didn't understand, but, like, it was so confusing in the moment.
It's totally okay. I still remember, probably been about 5 or 6 years, a student I had who, very much exactly the reaction you just had now. She came in the morning for a couple of times because she just felt like she just was struggling to get a good score on a practice FRQ. And all we did is what we're doing right now. We just patiently talk about it. Like, you don't want to rush, you don't want to get in a hurry, you just want to keep talking and talking and talking until you reach a point where you're like, oh, I can see it. I don't know why I couldn't see it, but who cares? Now I can. You know what I mean? So here's the box I wanted to show you. And it goes back to that idea of learning to think of each step independently of another step. Don't try to think of the steps together. So I used the fundamental theorem, but then I got to here where I had to figure out, okay, how do I find the value of any integral? Well, my first option is I'm going to use a calculator. My second option, I'm not sure, they might test you on that this year, but it's a little hard for them because they are allowing you to use the calculator. Here's where you'd have to find the antiderivative and then plug in the limits, like using like U substitution or something. U substitution is a fair question this year, but it's a little hard to test it because they're allowing you to use a calculator. So they might, but it's going to be a little hard for them. But area is my other method. So that's what I did on this problem, is I paid attention to area to find the value of this integral. And when I'm finding...
Oh, I found it on the screen.
Did you find it, Kenzie?
Yeah, I was just wondering where it was.
Gotcha. No, good question. You kind of have to help me now, Kenzie. You want me to keep talking about this one? You're feeling like you're okay?
No, I'm good.
Okay.
Wait, what does RS mean?
Oh, Riemann sum.
Oh, okay.
Yeah, that's one method that I'd say pretty good chance they could test you on it. The fact that the test is only 45 minutes means they're definitely going to have to make choices on what they test. But I have been giving you Riemann sums in the practice tests just because there is a chance. So.
When will we know, like, or like the exact formula, or like the exact, no, not formula, format of the test?
So, as far as I know, they've given us that. They said there'll be, and that's what I've tried to replicate on these practice tests I'm giving you, that there'll be 2 questions, I can't see how they can do it other than to make each question have multiple subparts, like A, B, C, D. What I do think will be different is in my practice test, like the one we're looking at right now, I don't have a way to create these problems on my own because they're just far too creative. So what I do is I take old tests and I'm kind of pasting them together. So like on this practice test, question 1 had 2 different FRQs with multiple parts, and then question 2 is similar. I think on their test there will be only one FRQ, but then question 1 might have parts A, B, C, D, E, and F, and then question 2 will only have like parts A, B, and C. But they haven't given any more information as to the details of what the test will look like. So what I'm giving you is my best estimate as to about what you'll see. I don't know if that answers your question, Kenzie.
Yeah, it does.
Okay.
I'm like, how we're gonna turn it in? Because we have to take a picture of our work, right? And then we send it in.
They said there were 2 ways, Josie. They said that they're actually going to provide a way that if you want to type your response, you can. I'm not really recommending that. I think that might take a long time to get it typed up and look how you want.
That sounds so hard.
Or like you said, Josie, they said that you would be allowed to take a picture and just upload the picture, and you have a 5-minute time period to do that. So
We have, like, let's say for example, the first, 20 and shit, and then what, like, is the time, like, they're gonna, like, show a timer, you have to, like, picture of it, 5 minutes of it.
what I, sorry, Josie, I didn't mean to interrupt. What I understand is that you'll sit down on May 12th, I believe is the date, and you will log in somehow, and then precisely at 12 o'clock our time, they'll make the question available to you. And so that'll be the first time you'll see the question. And I believe you'll be able to print it out, but I can't guarantee that. I don't know. And then you'll work the problem on separate paper, and then after 25 minutes they'll say done. You have to stop, and they'll close the question so you can't see it anymore, even though you could have printed it, I suppose. And then they'll give you 5 minutes to get it uploaded, and if you don't get it uploaded in those 5 minutes, then it won't count.
In those 5 minutes, like, work on it.
Say it again, Josie.
In those 5 minutes, work on it.
You're not supposed to be working on it during those 5 minutes, no. You're supposed to have those 5 minutes to simply take the picture and upload the problem. I suppose that's where you are on your honor to not keep working on it. So, does that answer your question? Go ahead.
I'm not gonna, like, have
Say again, Josie. You cut out a little bit. Say it again.
I'm worried that and then I'm gonna have some not be able to, like, upload or something.
Talk louder, Josie. I still can't hear you.
I'm just worried that it's gonna get to the test and, like, I'm gonna have a problem with my computer and I won't be able to upload my picture or whatever.
I have to be honest. I would have the exact same worry. Yeah, there's not a way around that one. We're just, I totally agree with you. The odds are small, so just try to think positively. But I totally relate to the worry. Yeah. What else would I say that would help with that? Maybe they're supposed to be releasing soon some more details about how this all works, and I'm hoping they'll release like some sort of practice so you can actually practice uploading. So at least you'll be comfortable with the tools they're giving you, you know what I mean?
Yeah.
And that way you can say, okay, no, barring some really unforeseen event, which this year is full of those, of course. So I don't know. I don't know how to help you on that one, Josie, other than just keep reassuring you that there's a 99.999% chance everything will go okay. You'll take the test, you'll take the picture, you'll upload it, it'll be all right. So, but I am hoping they'll give you some way to practice that. If not, I will actually That's a good question. I think if not, I'm going to design something that won't be their tool, but at least will give you the feel of it. You know what I mean? Like where I'll expect you to do the same thing, like take a clear picture, upload it to me, and then I'll kind of email something back and say, yep, that worked. I can see everything perfect. You know what I mean? To hopefully give you some confidence that that's all going to work okay. Would that help?
I think so, yeah.
Okay.
Figure that out, yeah.
Yeah, I don't ever want to give you busy work, but those quizzes I sent out earlier, I was a little worried they were kind of busy work, but I was trying to get a point across, so. David, just making sure you can hear me.
Yeah, I can hear you.
Okay, very good. There are just the four of you right now, Amanda, David, Josie, and Julia. Any of you can ask a question about anything.
I have a question. I was grading the 2012 test, the one that was due today,
Uh-huh.
and I have a question on, now I can't find the problem.
You're okay, just take your time.
Questions
So, which part?
but now I can't find it now.
Yeah, take your
It
time.
was the one where it was 40, I think.
Say
I'm
again.
gonna go for a bit. I haven't taken that one.
You're good, thanks Amanda. I'll just text out when we switch questions again, so.
Actually, it was 4B, I'm sorry.
No worries. Hold on. Okay, let me stop the other video here.